Hello guys, this is going to be 2D wind tunnel simulation, project 1. These are all the sections, so like settling chamber, contraction, test section, diffuser, 4 sections. I'm doing the case for 60 Hertz right here, and yeah, so let's get straight into it. So let me actually just pull this up, move this to the side. Okay, awesome. So click on fluid flow fluents, and then drag here. You want to click on geometry, go here, and then click it, switch it to 2D right here, and go back here, right click, and I'm using new design modeler. It's going to take a little time to pop up. And then first things first, we want to change these units to inches. Then you're going to click on the positive Z direction, and then XY plane. We're going to zoom out a little bit, so we're not surprised when we put in the dimensions. And so we're going to go right ahead into sketching right here. I click on line, and then we're going to make a series of 4 lines. I'm going to dimension them as I go. So I'm going to do dimensions here. Bam. So the test section length is going to be 15 inches. So here you go. And go back to draw. And go right here. Do that. Dimensions. So the contraction chamber is going to be 24 inches. Wait, hold on. 24 inches, just like that. We're going to go here, pan, and we're going to move this like that. It's easier to see the line stretching out like that. So we're going to do another line here, and then this is going to be your test section. And then your test section is your shortest section. It's going to be 12 inches. And then we do here, the last section, it's actually like 42 inches. So here, bam, we're going to switch it to 42 inches, just like that. Alright, and then we're all set. And then now, I'm going to go to draw. I'm going to make a couple of vertical lines like this. And then we're going to go to constraints here, bam, and then we're going to hit midpoint. So we're going to click the line, and then we're going to click on the point that we want to be the midpoint. So bam, bam, midpoint, bam, bam, midpoint, bam, bam, midpoint. And we can do this last one over here. It's actually very useful, I found out. So constraints, midpoints, here, here, there we go. So then we're going to dimension these vertical lines. So this one right here is going to be the height of your settling chamber. So it's going to be 22 inches. This one right here is the end of your settling chamber and the beginning of your contraction chamber. So that's also going to be 22 inches. And then here we have the entrance of our test section, which is going to be 6 inches, like that. So this is the exit of our test section, which is also 6 inches. Forgot to click this. Not 65. 6 inches. There we go. And so now we're going to connect these with the line. So we're gonna do here, 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 this, and then this right here is gonna be our diffuser, and then this has an angle that relates to it, and we're gonna see that in a second, how to do it. Okay, and so now we're gonna go to dimensions. We're gonna do angle dimension. So we're gonna click on this line right here. Then we're gonna click on this horizontal line in the test section right here, and that creates an angle right here. I'll put it big here so you can see it. And then, so the neat thing is you can play around with the angle and then make sure which direction you're going. So if you put 180, makes both of it changes both of their angles. So that's really neat. You don't have to double dimension. So it went this way to do 180. So we got to subtract 3 degrees. So do 177, and then we got 3 degrees here, and then 3 degrees here. So we're all set with dimensions. And then now we're going to do something here and modify. We're going to select on this trim. So then we're going to click on the lines that we want to trim. So we want to trim everything that is inside the wind tunnel, because we don't want this interfering with our analysis. Okay, awesome. So now that we've done everything in inches, thinking ahead, change this back to meters. Actually, no, before we do that, we're going to generate our sketch first. So we're going to go to Concept, Surfaces from Sketches. You're going to click, you're going to click Apply here. Oh wait, hold on. There we go. So sketch right here. Bam. All this should be highlighted. And then you click Apply. All this should be blue. And then you go to this button here that says Generated. Generate. And then bam. And now we have this generated. We're going to do a little something here. So we're going to change our units back to meters for this specific reason. We're going to go back to sketching. We're going to go to dimensions. And so we're going to do from this line, hold on, okay, to this line. Oop. Okay, so we're going to do horizontal line from this point to this point right there. And so this tells us right here our total length. So write this down for later, or just keep that there so you can see it. So 2.3622. So we're gonna click on generate again just in case. Minimize this. There should be a green check mark right here, so that's good. So we're gonna go here to mesh, right click, and then edit. Alright, and then the meshes sometimes take a little long to pull up, so a little bit of patience. You can, okay, I think we can go ahead and edit now. Boom. Okay, so now we have this. So we're going to click on mesh. We're going to change our element size right here to 0.01. And that's going to make our mesh, you know, a fine mesh, basically. So we're going to right click on mesh, insert, we're going to go method here. So it needs a geometry to latch onto, so you're going to click on this section right here. Click on the sketch. I'm going to click apply here. Boom. And that creates our body here. And then we're going to change the method that this gets analyzed, or that this gets meshed, and switch it to triangles. Alright, and then after that, we should be all set to generate our mesh. So, go back here actually, and then we're going to generate this. And then there we go, our mesh has been generated. So now before we move on, we're going to click on this section right here that says edge. Then we're going to control click on these walls right here. The top and bottom walls of the wind tunnel. All around like this. You're going to hit N on your keyboard. Like this. And then we're going to name this wind tunnel walls. Like that. Right? And then we're going to select this one. Hit N on our keyboard. And this is going to be velocity inlet. Like that. And then this one, our name, and this one's going to be pressure outlet, like that. Alright, and then now we have everything we need. Click generate again, just in case. Then we're going to minimize this, right click on the mesh and make sure you update it before we move on to the setup. So now we're going to right click on setup, edit, and then this is where we have to do all our values and stuff. So click double precision, then 2 solvers, start. And this one takes a little bit longer to generate than the mesh. Should be almost done at this point. Alright, so I think it's done now. So done. Click OK, and then it should be looking like this so far for you guys. And then we're going to click on models here. We're going to turn our energy and turn it on. We're going to double click right below it on viscous. So it opens this window right here. So we want to change to K epsilon. I'm going to turn on enhanced wall treatment. I'm going to click on these boxes, turn those on, click OK. And that's everything we need for models. And then check your materials, just in case, something I learned. And then you're going to double click on boundary conditions. So this is where you need your calculated V test section velocity right here. And so for me, I got, plugging in the 60 hertz there, you get 14.622, 5622, sorry. And then you need to do A1 V1 is equal to A2 V2. And so your A1 is going to be the height of your settling chamber right here. And then your A2 is going to be the height of your test section, so that's going to be 6 inches. So then if you put that in your calculator, right, you do 6 divided by 22. That gives you, that, and then times 14.5622. So that gives me 3.9715, which is what we're going to put as our inlet velocity right here. So we're going to click on that, and then we're going to click edit. So the velocity I got can be as accurate as you want it to, but just for accuracy's sake, we're going to put 3.9715090909091. You're going to apply and then close. Alright, we don't have to do anything else here. And after that, we're done. So you click on, you double click on initialization. We're going to click initialize. And it's going to throw this warning over here. Ignore it. And double click on run calculation. So you can put like 150. That's what I did. You put as many as you want, really. But, you know, having a large number of iterations helps. So I'm going to click on calculate, and it's going to throw us this really nice looking graph. There we go. All the pretty colors. Awesome. So I got this. If it doesn't look like this, go back, redo something. Something went wrong. This is what it should be looking like, approximately. So now we're going to go here to the left, and we're going to click on graphics, option called contours. And here, you want to click all of these right here. And then you're going to click save/display. And then look at all the pretty colors. So high pressure, low pressure, higher pressure. Yeah, and then so you want to take a screenshot of this, and then you go to dynamic pressure, do the same, take a screenshot of your dynamic pressure, and then you want to go to total pressure, save display, and then you want to take a screenshot of your total pressure. And this is really cool, you know, because what we learned in class, like along the center line of your processes in an idealized, isotropic case, center line, your total pressure should remain constant. And so that's reflected here. So that's really cool. And then lastly, you want to do your velocity. You do your velocity here, then save display, and boom. So you have your maximum velocity in the middle. And take a screenshot of this as well. I got a maximum velocity of 15.7. That is higher than calculated. But I think that's fine. And then what's really cool here is like you can see like, no slip condition probably right here. And you have like a little boundary layer forming right here, maybe. So that's pretty cool. Alright, so we're gonna close that. And then the next thing that we want to do is, so we're gonna click on surfaces, double click on surfaces. And then not on surfaces. Right click on surfaces. You're gonna click new and put line. We're gonna create a new line here. And so this line is gonna be your center line with which you get all your plots from. So in order to find this, we already did this. So you go to your right here, and then it's just this length right here. So go to, there we go. It's going to be this 2.23622. It's 2.23622. Go here. We're going to go x0, x1. It's going to be 2.236, or was it 3622? Hold on. I instantly forgot. 3622. There we go. Alright, and then we want to create. And so if you want to make sure that the line you created, like how do I know this line is like correct? So I'm going to click on contours again. You can double click on the contour you already made. It's fine. What is this line? Hold on. You want to unclick those and then click on the line you just created, and then there. And then if you want to see if it's in the center line, you can click on wind tunnel walls, and then boom. So it should look like that when you verify it, which is super cool. So we're gonna unclick, actually no, we're gonna unclick this, click back on everything, like that, and then yeah, so save display, velocity magnitude, there. So then we're gonna go down here, we're almost done. So plots is the last thing you need. You're gonna double click on XY plot, and then you're gonna click on the line you just created, so it's gonna be your center line. And then you're gonna put pressure, static pressure, then actually let's do velocity first. So velocity, alright, they want the plots of all this. So you save your plot, that's what it looks like. Right? Nice increase, constant around the test section, decreasing back in the diffuser, but not all the way to 0. Right? So you want to save this plot. You want to click write to file, write, and then do, here we go. So you can do video velocity plot. Alright, bam. And you do that, and then you go to pressure, and you can do static pressure first, unclick this, make sure your plot makes sense. So, you know, maximum pressure, maximum static, you know, goes decreasing in the contraction chamber, almost constant in the test section, and then recover some of it in the diffuser. Cool. Then we're going to go ahead and write to file. I'm going to go ahead and, I think I was there already, but as we're going to do video static pressure plot. Okay. And you do the same thing to dynamic pressure. You first want to just look at the plot first. So not a lot of movement. So the dynamic pressure should look similar to the velocity plot. So that's fine. And we're going to write to file. Sure, yep. Okay. So video. Why is it not typing? Video dynamic plot. Okay. And then last but not least, we do total pressure. And save plot. And then, so this is a little confusing, right? It should look like this. But if you notice here, like your variation is really, really small. So when you really look at it, it's almost constant. There is some little variation, but theoretically it should be just one straight line. But this is fine for the plots. So when we write to file, and then video, again, video, total P plot. We hit OK, and that's it. That's pretty much everything. Yeah, I hope this was helpful, and hope you guys' project goes well, or if you're just doing this for fun, and have fun. All right, bye.